Hi everyone, welcome to the knowledge session. In today's session, we will learn about the basics of Kafka Stream, presented by Anushka Agrawal, and I am a senior software consultant in Nodus. So let's first begin with some knowledge etiquettes and try to follow them in the session. Firstly, we have punctuality. So we should try to join the session 5 minutes prior the session starts so that we can conclude and start on time. Next is feedback. Feedback is very important and it helps the presenter to improve better in future. Next is silent mode. We should always try to keep our window in the silent mode and try to avoid disturbances and avoid leaving the window unmuted after asking a question. So let's discuss the agenda of today's session. We will start with the basic introduction of Apache Kafka. Since Kafka Stream is the component of Apache Kafka, we will discuss what Kafka is and how it came into picture along with a simple use case where I'll tell you how actually Apache Kafka works. Then we have introduction to the core concepts of Kafka. We will learn about the basic terminologies one should know about Kafka, their relations if they exist, and an example showing the use case for the same. Then we have connect core concepts. So we will know what they are, how to use them, use cases, and how advanced they are, which means that what actually makes them advanced. Then we have, after that we will discuss and learn about the real picture, which is the real time processing of Kafka Stream, and the focus will be on what the real time processing is and how Kafka Stream plays a vital role in it. Then, to take a bit deeper, we will learn about the concepts of Kafka Stream, means the basic concepts. And at last, I will demonstrate it using a simple example. The main thing about this session and this demo is that we all know that the Kafka is mainly implemented in Java, but in this session, I will implement it in Scala as well. So let's start. So before learning about Kafka, let's take a break and think why Kafka came into picture. So the thing is that data is growing exponentially. And the biggest problem was to deal with huge amount of data being populated at a very rapid pace. So the evolution turned around in a way that earlier we used traditional databases where we saved our data in REST it and then we perform some operations on data using some queries or other tools, processes, and transform the extracted data, and then at last we get some insights of the data. But the next problem was when we can't wait to get the data piled up somewhere like a database, data lake, data factory, etc. Rather, we need to perform some operations and processing on these streams of the data. Means we have to process and transform them by performing some operations and queries on the data to transform it before it gets piled up in the REST state anywhere it can be. So we need a tool for this purpose, and this is where Apache Kafka came into picture. Let us consider a real life scenario where data is being generated from a number of resources like social media, hospital records, insurances, IoT systems, etc. So we segregate them into some categories. Okay, like this is coming from messaging, we have this from website tracking activity, some logs or different system stream data which need to be processed and go on, and matrices, etc. Now one solution might be that we have different tools text for different data types, but this can be the worst approach because we need to know what type of data we are receiving and what needs processing needs to be done. So every time we need different tools for different types of data, so that is very complicated and that could not be a best practice. So instead we have a tool that we can work on for this use case, and this due to this Apache Kafka came into picture. And there are multiple other streaming platforms as well which have one or the other advantage and disadvantage over the others. Like we have again Apache Kafka, Apache Spark, Kafka Streams, Amazon Kinesis, Apache Flink, and many more. And in this session, we will learn only about Kafka. So, what is Apache Kafka? According to the official documentation, Apache Kafka is a distributed streaming platform, which simply means creating and streaming the real time data streams and is highly scalable. So, don't worry if the definition is a bit confusing for now. I'll give you an example as well. So, it is a client library for building the applications and microservices and unbound data, that is, data can be infinite. And how it can create and process a stream is by interacting to the cluster to do the same. Data is represented in it in a key value record. So in Apache Kafka, whenever we need to create a stream or we need to pass a data from producer to consumer or via a stream, so the data should always be in a key and value format. So let's have a look at Apache Kafka. How does it look like? So as I told you that it is nothing just creating and processing the stream by interacting with clusters, which is a group of brokers and also known as Kafka server. So it starts with creating a stream. Like let's take a scenario of the hospital where we have a number of patients with us and their data is being generated like of ECG, heartbeat, etc. This data is being sent to Kafka server with the help of Kafka producer. Once the data is at Kafka server, and then we start consuming the data from Kafka server and process it. Say for example, if while processing the data, we encounter a serious issue with a patient, so we can trigger an emergency call message to the doctor so that the patient can be immediately observed. So this is how actually Kafka works. Mess from the producer, we get the data, passed to the server, and then some processing or operation is done. Some transformation is made to the data if required, and then it is saved to the consumer. And the producer could be a single system or a group of systems. It is just the data system you need to use to send the data to the Kafka server. Now let's talk about the Kafka core concepts. So in general, we have total of 8 terminologies which you can see while using the Kafka, starting from producer, consumer, broker, cluster, topic, partitions, offset, consumer groups. And another one which we might have missed out is zookeeper. So before moving further, we might have a question that it's okay, we are creating, streaming, and processing a data, but which type of data does Kafka work upon? Must be structured, semi-structured, or unstructured? So the answer is very simple. It doesn't work depend upon the type of data. For creating a stream and processing a data, it the Kafka works regardless of the type of data, which means that your data could be anything like PDF, text file, log file. It just stores the data in the Kafka server. It may in the form of array of bytes, which I will also demonstrate in the demo later on. And it depends on your consumer and producer API how you are dealing with that data. Now let's learn about the terminologies. So first we have producer, which is an application used to send the data to the Kafka server. And this data is actually a record. Let's say if we have a log file and we want producer to send it to the Kafka server. So it will do it line by line by transforming them into array of bytes. And for example, if we have a database, so it will read record by record, form them and transform them into array of bytes, and then send it to the server. So once the data is at Kafka server, now we have to process it. And this starts by consuming the data. So we have consumers. which consume the data and processes them into batches. Now, consumers are just receivers, and communication between consumer and the server is bidirectional. That is, the consumer consumes some specific number of records from the server, processes them and sync them, and then again consumer consumes the new record from the server. Actually, this process goes on. Then now let's talk about the Kafka server, which is again a cluster. And we all know cluster is a group of brokers, and these brokers are like computer systems, each representing a single broker. So now we have topics. So there are a number of producers sending different types of data. So it would be confusing that which type of data is stored where, and where the which streaming is storing which kind of data. So that is why we have the topics. So topics are like just schemas in the table, in the databases that we have, SQL, SQL or whatever. But the difference is that schema is not defined here. There is no specific structure that it should be in this format or that format. It is just in the key value format. Then, and also one more thing we need to know about topic is that the topics always have a unique name given to the stream or data sets. Now we have topic partitions. So what if we have number of data and a huge load on them? In that case, the Kafka server may face failure due to memory or something else. Then what can we do? Then we can try and distribute the load by creating topics at broker, which is known as topic partition. As Kafka is distributed system, so we can do this. Then defining a number of topics and topics partition is just as per our business requirement. And this is design driven and must be decided very wisely. Next one is partition offsets. Well, if we are storing a similar type of data in a topic, then it needs to be done in sequential way by assigning a unique key to all the messages arrived and assigned by the broker itself, and is also immutable. Then we have a consumer groups. We already have learned about consumer. Now what the consumer group is? It is a group of consumers to share the workload. Let's take an example. If we have a large number of files to process, so what we can do, we can combine group of consumers and make a consumer group, so that the load that we are having due to processing of multiple files or heavy huge loaded files can be distributed and it can be easily processed without any hindrance or time delay. Now one thing left is that the one terminology left is zookeeper. Zookeeper is just something that holds the metadata. In the upcoming time, according to some resources, Confluent Kafka may also remove it. Now let's talk about Kafka Connect. So what is Kafka Connect? So Kafka Connect is basically a system which can be placed in between the data source or sink and the cluster. That is, it can be placed between the source or the sinks and the cluster. Now, why we need it, how it works. So let's take an example. We are running an enterprise, okay, and it is almost impossible to create a standalone application that does everything. As an enterprise, we have a bunch of independent and running applications. So some of them are from third party and they may own it, or you may use some data which has been created and owned by some other system, like the financial ones or invoices or etc. So in this case, you may realize that we don't have the source code, or the code is like non modifiable because it is holded by the third party and we are unable to modify it. Just we can use that data. So in that case, it is possible solution is to create an independent producer, or here comes the connector. So here in this type of situation, we can use the connectors. So what we have to do is to just place the connector in between the source and the server, because here the source is our third party which is immodifiable, and we need to pass the data to the server. So we can place the connector between the source and the server and just configure it. And similarly for syncing the data also, we can place the connector in between the server and the sink and configure it. Also, the connector placed in between the source and the server is called the source connector, and the connector placed in between the sink and the server is called the sink connector. In simple words, it is a component of Kafka for connecting and moving the data between the Kafka and the external systems for the purpose of data integration. Like we are placing the connector between the third party and the server, so it is helping, acting as a source connector and helping fetch the data from the external system. And likewise, if we are using for the sync uh, part, then it acts as a sync connector and helps store the data and process it to an external system. So let's take a very simple example. Consider a scenario where we have to move a data from database and send it to a Kafka cluster. So what we need to do is download a JDBC connector, place it in Kafka Connect, place it as a Kafka Connect, configure it according to your requirement, and just we need to run, and that's all. Let's take a view of Kafka Connect. So consider we have to transform the data from source to sink via Kafka cluster. This time, the source is typically our database, sink is our Snowflake, and we do not have to write a code. Okay, just we have two connectors with us. First is the JDBC one, and the second is one for the Snowflake. Placed in between the Kafka Connect and run, and we can configure it also as per our requirement. Even if we want to create our own Kafka connector, then it is not that hard. We need to just use the Kafka Connect framework, which is open source, and at high level you just need to write only two Java files, source and sync connector and source and sync task. Make a zip, archive it, and share it for use. This is how a Kafka Connect Advanced is. Now about real-time processing. So earlier I discussed the scenario about the hospital. Let's discuss that hospital scenario again, where we have a lot of patients and the data is being generated from the reports and are being sent to the Kafka server. We have two options now. First one is to use the Kafka Consumer, which again may be a bit easy to implement and can be used for streaming. So the consumer API is an application that retrieves the data from the Kafka server, inside which the Kafka producer is producing the real-time data that we are getting from the patient's records. Okay, but how a consumer works? So basically the consumer works is by consuming a number of records, then in a specified time duration. Okay, in a specified time duration, a consumer is fetching the number of records from the Kafka server, and then it is taking a gap and then processing and transforming that data and performing some operation on it, and then it fetches against the data from the server once the transformation is done. But what happens if if the gap that is provided, that is taken by the consumer for transformation part, in that time something happens or something serious problems occurs to the patients, any of the patients? So at that time our consumer will fail, it will not be effective, and we will not be able to notify or send any message to the doctors for the patient that a serious problem has occurred, or whatever the scenario is. So at that time we need Kafka Streams. So in that case, Kafka Streams will help us to deal with the real-time streaming data. So Kafka Stream API is a library for building the streaming applications. Apart from that, there is an alternative also, which is KSQL, which offers an interactive SQL-like interface for streaming and processing. Now let's look about the Kafka Streams, which is again a library for building the streaming applications. As I've told you earlier, that the source is not directly connected to the sink, which means that the Kafka stream for the Kafka stream, the input data must be streamed from the Kafka topic first. And it is fantastic when it comes in parallel processing, scalability, fault tolerance, etc. And moreover, we do not require a separate cluster to deploy it, and we can deploy it anywhere, wherever we want to require. If we talk about the degrees of Kafka stream, then it is interoperable with with streams and tables, and it is also fault tolerant, scalable, and efficient local states unit testing tools that we can deploy it in containers as well and manage it using Kubernetes. For operations aspects, yes, we can do the grouping and continuously upgrade the aggregates accordingly. Also, it allows us for with flexible windowing capability. We'll show this in the demo later on. So before going to the demo, let us conclude it. We have unbounded data, and thus Kafka Stream comes into picture, which is a Java or Scala library, and even we can embed it into our microservices and we can deploy it anywhere we like. So let us go to the demo. So for as I earlier mentioned that I will be showing my demo in the Scala. So for Scala, we need to create a build tool, and I am using SBT here. So for that purpose, we will be creating a build.sbt, and in this build.sbt, I have created a root module that has a name Kafka Stream Demo, and then I'm using here the Kafka version as 3.0.2 and Cersei version as 0.14.2. And here we can see I have taken 6 different dependencies. So as we can see, the first 3 are of the Kafka and the rest 3 are from the Cersei. So as we are using Kafka Streams, so I have taken the Kafka client here, Kafka Streams, and we are building the project in the Scala, so Kafka Streams Scala. We can think that if we are using Kafka Streams Scala, then why we need Kafka Streams? But there are libraries that are used from Kafka Streams directly, and we do not have them for Scala. So that can be used directly from there. And for Scala, we have also some libraries, so we can use them. Then we have 3 other dependencies here, that is from Cersei. So here we can see what is Cersei. First, let's know about Cersei. So we will use Cersei in order to serialize our data structures to JSON and then send it to Kafka server. Alternative, there are many alternative of Cersei also. We can use Avro, Cairo, and Google Protobuf as well. But here for showing the demo, I am using Cersei. So here we are using Cersei core, generic, and parser. So the flow takes place here in 3 steps. Source, which emits the element and creates a stream. Flow transforms elements along the way, means that they does the transforming of data. And sink, where we can ingest the elements. First, let us take the look into our models, which will be our source from where we will be emitting our data. Okay, so here I have defined 2 case classes. One is info and another one is manager info. So here info has multiple fields, that is id, which is of type id and which is actually an integer. Then we have name, that is of type name and is actually a string. Then we have a studio, likewise of name, it is of type studio and is actually a string. Similarly email and manager as well. Now as we have created a case class info, we have another case class, that is manager info. So manager info also has many fields like id, name, studio, and like info case class, we have id also of id type, which is actually an integer, name of name type, which is a string, and studio of studio type, which is of type string. Now, yeah, so now we have models from where we will be getting our data, which type of data. So here, actually when we will be creating a stream, our source will be of type info and manager info that we will be using. But for streaming it, we will be using a serializer and needing a serializer and deserializer, for which we have used the SERC for parsing and transforming the data into JSON and then further processing it. So here, firstly, we had the info case class, and we can see I have created an implicit, which is info SERD. Okay, and it is returning a SERD of type info. So here, firstly, I have created a serializer. So this serializer is taking an info and transforming that info to JSON. And for pretty printing, we are removing all these spaces from it and converting it into bytes. So it is overall taking an info, parsing it, and converting it into array of bytes. If we will try and annotate it also, so we can see it is taking info and converting it to array of bytes. Okay. Similarly, we have created a deserializer. So now we have, when we had info source, converted it into array of bytes, that is a stream, and now we need to convert the array of bytes into again info, that was our original data type. So we need to create a deserializer. So now we have created a deserializer here that takes the array of bytes, and then we create that we convert that array of bytes to string, and then we decode that string into type info. So when we are decoding that string, we need to specify in which type we need to convert, because how will the deserializer know without letting them. So we are providing the type here info, and it will convert this string into type info. And you can also see that I have used two option here. So this two option I have used to be on the safer side. For example, while deserializing, by any chance, if this deserialization fails, the parsing fails, and we are unable to process the data, parse the data. So at that time, to avoid any failure or any breakage in the application, I have used two options. If we will get the data, so that can be that we can get in some, and otherwise we can get it in none. So for to avoid this failure, it is a best practice in these type of cases, we should use the data to be serialized or deserialized in option of none, sorry, option in option. And if we annotate it, we can see it is taking array of bytes and returning it to option of info. Now we have created this deserializer and serializer. Now we need to combine it to SERD to use it later in our streaming. So in this SERD, we have a from function. This from function takes a type of which type of data we are giving, and also it takes the serializer and deserializer. As we can see in the implementation also of from function, it is taking a type, and it also needs a serializer and deserializer. And serializer should take the same type and convert it into array of bytes, and deserializer takes array of bytes and converts it into option of that type, and it will eventually return a SERD of that type. And as we can see, this is how we have created the implicit for info SERD. Now, in the similar way, as we had two different models, one is info, one is manager info. So we have created the manager info SERD as well. So here we have created an implicit, we have defined a def, and it is taking manager of SERD. So we have created a val serializer that takes manager info, converts it into JSON, and for pretty printing we have removed all these spaces and we have converted it into array of bytes. And it is similar to info. We can see the type annotation as well, taking manager info, returning array of bytes. Then we have a deserializer which takes the array of bytes. Then we are converting that array of bytes into a string. Then we are using the decode method and passing that string to be converted into manager info. That was our original data type. And then for the safer side, we are converted it into two options. And we can see the type annotation here as well, that it is taking array of byte and converting it into option of manager info. And in the similar way as we did for info SRD, we will use the serializer and deserializer here. So we will be using the from function of SRD, pass the type manager info and pass the deserializer and serializer to it. Now here it is a small example. So we have only two models. One is info and one is manager info. But we do not know there can be a large scale application also running that can have multiple type of data. So in that case, we can create a generic implicit also for serializer and deserializer as well. So for defining that, we have taken a type that will return SRD of a type, created a serializer that will in the similar way it will work. Take that type, convert it into JSON, remove spaces, and convert it into array of bytes. Then for deserializer, it will take array of bytes, convert it into a string, then decode that string into that A type, and also return the option of array of bytes. Sorry, option of A type. Then we will combine that serializer and deserializer into 30 with from function, and then we can use this later on. So this was how we have created the serializer and deserializer using the SERD. So we have seen the models we have seen, that is our source, that is the data type of our source. Serializer and deserializer we have seen, that will help us parse the data while streaming. Now let's create the stream. So for successful implementation of Kafka Stream, we need to follow three basic steps. One is creating the topology, processing it, and syncing it. So we have three basic steps. So here firstly, let's create a topology. So topology is like creating a builder. So here I have used the streams builder for creating a builder. So val builder is equals to new stream builder. This will help build our topology in Kafka streams. Okay. Then we need to create these streams. So for creation of the stream, we had two types of data: info data and manager info. So firstly, let's create the stream for info. So here we have built the topology. So builder.stream. I have already told earlier that the streaming of data takes place in key value pair. Okay, so we have to, for passing the data into the stream, we need to provide a key and a value to it. So here the model that we have defined earlier has ID, name, studio, email, manager. So there are chances that ID can only be the primary key here. So we will be passing the ID as the key and rest info as the data. And then we also need to provide the topic in which that can be stored. So here we are passing the info type of data. So I have provided the name as topic info. So for streaming of data, it is necessary that we provide an implicit to it for serializer and deserializer. So this serializer that we have created earlier will now come into picture. So I have created a new serializer here that will automatically call the info surdy from here. So this will be used, that info surdy that we have created already will be called here and will be used as a serializer and deserializer in this info stream. So now when we are passing the data, we have created a serializer for info, but we have not created a serializer for ID. So how will this not create a problem? Because we are passing both the type of data, the key also and value also. So the processing will should be done for both the type. So here in the imports, this Apache Kafka stream provides Apache Kafka provides a serializer for int and string both. So I have directly imported this from here, and this will automatically parse and serialize the integer key that we have provided here. If I might have been using the string type of value as the key, so that can also be used here, so that we do not need to create the serializer for them. Now we have created the information stream. Now for as we have created the info stream, now we need to perform some operation and transform it. So for info stream, we are creating a filter here. So in that filter, we are filtering the studio which has type of which has a studio sorry the information which has studio name as Scala and the ID which is less than 2001. So we are only filtering this type of data. So this type of processing can be done um, in a stream. So for info stream, this can be done. Now, as in Scala, we have maps and flat maps. Likewise, Kafka stream provides map values and flat map values as well. So this info stream from here, if I want to fetch the all the values of a from my stream, but I do not care about what the key is and what it is doing. So we can use that, we can directly use the map values. This map values will fetch all the information from all the values of that key, and from there we are only fetching the names of the employees from that info. Now we can also flat map those values and convert it into a list and later convert into a string. So all the processing that we need, we can do it. As we have created a stream for info, likewise we can create a stream for manager as well. So here the topology that we have created was builder. We are creating a stream and we are passing the key here also as ID and the values as manager info, and again we need to pass a topic. So here the topic will be manager, and it also needs a serializer and deserializer. So is at this time the manager info serializer will come into picture that we have already created here, and this will be automatically taken as the implicit from here. Now this is the basic. Similar operations that we have performed on info stream can also be done on manager streams. Now we have created two different type of stream, played around and performed some operations separately on both these streams. What if I want to join both of these streams together? So for that we have a join window. So this join window takes a time duration. For example, I want to join both these streams, okay, and if by chance any failure occurs to one of these streams, and for infinite time we are waiting that when we will be getting the result for join stream or not. So at that, to avoid that waiting period of time, we provide a duration for which amount of time it should wait for trying to join the stream. If they are possible, else it will not join it. So here join window is taking the time which is which I have provided 5000 seconds. So this is the time duration that for which time it will try and join these streams. So for joining the stream, I have used info stream dot join and join the manager streams. Then we need to pass the operation also that we need to perform while joining the stream. So for join, as we see in SQL and pSQL, that for joining any of the two tables, we need a primary key. Okay, so here, but you can see I have not provided any primary key, but Kafka will automatically fetch this ID, and because the key is passed for both manager and info stream, so it will take these IDs, both the IDs, and it will take it as a primary key, and on the basis of this ID it will join the info stream and the manager stream. And then coming to the operation, while joining the stream, suppose I want to perform some operation and fetch some specific type of data. Once the stream is joined, I want that an operation should be performed, and it will take that if the info.studio and manager.studio is equal, then it will return that type of info, else it will return empty type of info. Okay, so I want this operation to be performed. So while joining the stream, I will pass this operation, and then I'll pass the time duration. So this join method is used. See, we can see the definition also here. This join method is taking two type of streams. Sorry, is taking two type of two types. Sorry, key and value, and it will take the other stream and also need a joiner, and it will take a implicit streamer joiner. Okay, so this all we have passed here, the time, operation, manager stream, and the info. So in this way the joining will be done, and now once the stream is joined, I want to perform an operation again to flat map all the values and convert them all to the list. So this will be performed once it is done. Now once this stream is joined, I want to store that again to somewhere or the other. So at this time, as I have passed the topic while creating the info stream, I have I have named the topic as info. While creating the manager stream, I have passed the topic as manager. So now while joining the stream for both the info and the manager, I will name the topic as process data. So when this joint stream is joined, this also needs to go to somewhere, some or the other topic. So we, because this is also a type of stream, we have not created something else like this is one stream, this is two stream, second stream, and we have combined both of these stream and made it like a third stream. So this also needs to go into a topic. So we have passed this joint stream to one of the topic, that is process data. And now coming to the last step, we need to build it. So we have created the topology in the beginning only, that is new stream builder. So we will be using that, and we need to build it. Once it is built, now we need to start our application and run it. So for starting that, we have used Kafka Streams. So we will be as new Kafka Stream that will take a topology, and that also takes some of the properties. So I have created that properties here. So we have to define some of the properties, streaming properties, and we will be using Java properties here. So there are basic three types of properties we have to define. First one is for the bootstrap. The bootstrap server means that the server from where we want to connect with our stream. So for example, here I have defined localhost 1992. So this is the location from where my bootstrap server will connect with the stream. Then I have passed the client for which you want to read the data. For example, there can be multiple clients at this location also, but I want to read the data for application only. So this is my client for which it will read the data. And because we are using SERD, so we need to define a class config also for the same. So for this we have defined SERD dot string SERD and dot get class. Now once we have provided the properties also, we have created a streaming application, that is Kafka Streams, that is taking a topology and also having some properties. And once this stream application is set up, we can start it using the dot start method. And for running this application locally, we will need to set up the zookeeper and the Kafka server as well. or either we can use the Docker image as well for running this application locally. I hope you enjoyed the session and got to learn about Kafka Streams more. Thank you for your time.
Okay, thanks Anshika for this wonderful session, and I would appreciate if anyone had to have any questions since this session was from scratch, and I believe that you have learned a number of things from scratch. Means how does the things takes place and why we need everything. Means you cannot use anything everywhere, so you might need means you got to know means when to use which one. So I would appreciate. So if anyone do have any question, please go ahead and ask. And even I would appreciate if anyone do have any feedback for Anshika, please speak up.
Yeah, Anshika, it was a great session. I got to learn a lot of things.
Thank you, Aman.
Any other question or feedback? Okay, so let's consider it as no. And meanwhile, if you do have any question, if you're hesitating for now, you can reach out to Anshika at any time on their message, and you can ask her any question at any time. So that's all for the session. Thanks everyone for the joining, and please don't forget to share your constructive feedback since it's very helpful for making the sessions more better and improved. Thanks everyone.
Thanks, Kuldeepak. Thanks, Anshika, and thanks everyone. Have a good and great learning day ahead.